Okay, so today we're going to look at Tuesday, 7th of January, paper 1H, higher tier, okay? And we're going to Miss Hayden Higgins solutions. So, as we know, this is a calculated paper. You are allowed, you've got the formula book here, so if you need any formulas, that's right here. Right, so we're going to start at the beginning, and then we're going to move through the paper. So the point A has coordinates 5, minus 4, and the point B has coordinates 13, 1. Work out the coordinates of the midpoint of A. So it wants in the middle of 13 and 5 for our x. The best way to do that is to add them together and divide that by 2. That's going to give us our x coordinate, and the same with the y coordinate, okay? Now, it doesn't necessarily matter which way round you do this. When you're adding, you're going to get the same answer anyway. So when we add them together, we're going to end up with 9 and minus 1.5. Okay, so that's 2 marks there. You get 1 mark for each one. The next question, the line L has the equation y equals 2 minus 3x. Write down the gradient of the line L. So the gradient is whatever is in front of the x. So our gradient is minus 3. Then it says, line L has the equation y equals 2 minus 3x. Does the point with the coordinates 100 minus 100 and minus 302 lie on the line L? You must give a reason for your answer. Now, one way we could check this is by substituting in the values. So we know our y is minus 302, which equals 2 minus 3 lots of 100. Minus 302 equals minus 298. This is not true. Therefore, the point does not lie on the line. Okay, perfect. So that's question 1, completely finished. Total of 4 marks there. Nice and easy. Okay, moving on to question 2. So it says find the lowest common multiple between 28 and 105. The first thing I would do is I would use prime factorization to find out the prime factors. So 28 I can make by 2 and 14. I'm circling my 2 because it's a prime number. 14 I can make using 2 and 7. And again, I'm going to circle my prime numbers. So 28 can be written 2 times 2 times 7. Now we can double check this because 2 times 2 is 4. 4 times 7 is 28. Same with 105. I'm going to divide this by 5. 5 times 10, 21 is 105. And then we're going to have 3 times 7. So 105 can be written as 3 times 5 times 7. Okay, and again, you can double check this. 3 times 5 is 15. 15 times 7 is 105. I'm now going to use a Venn diagram. So I have 28, 105. So 28, do they have anything in common? Now, the only number they have in common is 7. So that 7 is going to go in the middle. And then I'm going to have 2 and 2 left over and 3 and 5 left over. Now, when I'm looking for my lowest common multiple, I'm looking for A union B. Okay, so if this is my A and this is my B, I'm looking for the union. So everything that's So when we have double brackets, it's always good to make sure you show all of your working. I like to use the smiley face, but whatever you're comfortable with, please do. So m times m squared, minus 8 times 5, these points here, how am I getting from them? So if I have a look at this first line here, from this point to this point, okay, I have gone from 1 all the way to 15 and up 2. So scale enlargement will be along these lines somewhere. It'll be along these lines, but because it's a half, what I'm going to do is if I go across 14 and up 2, I'm going to half it. So that means I'm now going to go, there we go. So originally, if I go across here, it's 14 and up 2. So I'm going to half that, so I'm going to go across 7 and up 2. If I go across 7 and up 2, here is my new point. Okay, and this point corresponds with this one here. Now, you know you're doing it right if the point lands on the line. So same for this one here. If I have a look here, I've gone across 10, up 2. So I'm now going to go across 5, up 1. So this is my new point. Okay, and you'll also notice our trapezium here is 4 along. If we're scaling it down, it should be 2 along. Now that I have 2 points, I can actually draw this in because I know this is a length of 2. I know up here we have 1, 2, 3, 4, 5, 6. So I know I need to go up 3. 1, 2, 3. I know I'm doing it right because it's on the line. Then here I have 1, 2, 3, 4, 5, 6, 7, 8. So I need to go across 4 because it's half as much. And then join it together. So there is my new shape. Right, question number 9. Now this is a beautiful question, and especially it's 3 marks as well. So we have a right angled triangle and it wants us to find the length. The first thing we should be writing down is SOH TOA. So, SOH. Now, we know our O stands for opposite, H stands for hypotenuse, and A stands for adjacent. So our O is always opposite the angle. Opposite the angle is O. The hypotenuse is always opposite the right angle, and then we have our adjacent. Now, what it actually wants is PQ. So it wants this line here, PQ. Okay, so we need H, we have A, and we have an angle. Our O is no use to us, so we don't need to worry about that. We're now going to have a look for the formula that has A and H. So we're going to be using cos. So we know that cos of X equals A over H. Now our angle is 63, so cos of 63 equals our A, which is 24.3 over our H. Now, I would always suggest writing this out first before you rearrange. Now, you want H, so we need to rearrange. Now, there is a handy trick where you can just rearrange those. So we're going to get H equals 24.3 over cos of 63. Now, how that trick works, because it's really important that even though we know these tricks, we need to understand how it works. First of all, I want to get rid of the H on the denominator. So I need to multiply by H on both sides. So I'm going to get H times cos 63 equals 24.3. Then I want the H on its own. So I need to divide both sides by cos 63. They're going to cancel because everything on the numerator is multiplied by whatever's on the denominator. So then we're then going to end up with 24 over 3 cos 63. Okay, when I put this into my calculator, I'm going to get 53 point something. I then need to round to 3 significant figures, which is going to give me 53.5. 5. Okay, it's really important that when we're rounding, we make sure that we round completely to 3 significant figures. Okay? Perfect. Right, question number 10, inequality regions. So, it wants us to write down the 3 inequalities, okay, inequalities that define the shaded region. Now, they've already given us this line here. They've already given us y equals a third x minus 2. Now, the region we want is above the line, okay? If it's above the line, that means that y has to be greater than or equal to. So we can already write down our first inequality region. Okay, how do I know that it's greater than or equal to? It's because it's a solid line. If the line on the graph was a dash, that means our inequalities would just be less than or more than. Okay, the reason why it's less than or equal to is because the line is solid. We have a solid line that's less than or equal to or more than or equal to. Next up, we're going to have a look at these lines. This line here, we should all know that this line is x equals minus 1, because no matter any point I choose on this line, x is minus 1. X is minus 1. Line is x equals minus 1. And then I look, do I want, if I look, I want this side of the line. That's where it's shaded. So x is actually greater than or equal to minus 1 every time. Because every time, you know, our next available x is 0, which is greater than or equal to minus 1. Okay, so the last thing we have is this line here. Okay, so first of all, we can do this a few different ways, but I'm going to make sure that we fully understand what's going on. Here we have our y-intercept. So we know straight away that we're going to have y equals mx plus 4, because it crosses here at 4. We know that the line is facing in this direction, so our gradient is actually going to be a negative gradient. And then what we can do is we can draw a triangle to see what our negative gradient is. So when I like to draw these triangles, I like to draw them so they are exact. Now we can see here, we've gone from 0 to 2 is 2, 4 to 2 is 2. Now we know our gradients is difference in y by difference in x, which is 2 over 2, so our gradient is in fact 1. So y equals minus x plus 4. Now, do you want above or below the line? Okay, so we're having a look here and we want below the line. So if we have a look, we want below this line here. So we're going to have y is less than or equal to minus x plus 4. Okay? Okay, moving on. So our second question number 11. Right then, so this was quite a different question that I've seen before, but I still thought it was a really good question. So, Max invests $6,000 in savings account for 3 years. The account pays compound interest at a rate of 1.5% per year for the first 2 years. So straight away, without reading the rest of the question, I know that's a compound interest question. I know 6,000 times, if it's 1.5% compound, so that's, if we're adding that to 100, I want 101.5% after each year is what's going to happen. So I'm going to convert that to a decimal, 1.015 to the power of 2. This is going to give me 6,181.35. It says the compound interest rate changes for the third year. At the end of the 3 years, there is a total of 6,311.16 in the account. So what would really happen in this is we'd have 6,000 times 1.015 to the power of 2 times our new amount is going to give us our 6,311.16. So to find out what that new amount is, I'm going to get the difference between these two values. If I get the difference between these two values, I'm then going to be able to find out what exactly is sorry, not the difference, the division, because this one equals this one here. And if you want to get rid of anything that's multiplied, we need to divide. So essentially, to find out what I've multiplied by in that box, I'm going to have 6,311.16 divided by this, which we already worked out. So 6,181.35. That's going to give me 1.021. Okay, so 1.021. Now I know when I look at this, if I look here, I've got 1.015. I knew that was 1.5%. 1.021, I know that's going to be 2.1%. If you can't see that, the other way to look at it is 1.021. If I times that by 100, I'm going to get 102.1%. So that means that's an increase of 2.1%. Okay, next question. So I'm going to have to be flipping between screens for this one, if you just bear with me. So here we have a total of 80 men. We've got cumulative frequency. Perfect. So the interquartile range, I need to find the upper quartile and I need to take that away from the lower quartile. So the first thing I'm going to do is I know my median is 40 because when I'm looking at the upper quartile and the lower quartile, I'm looking at my cumulative frequency. Half of 40 is 20. So I'm going to go across here, down here, 38, I want to say. Okay, and then our upper quartile, so this is our lower quartile. Our upper quartile is 60 because that's in between 40 and 80. So I'm going to go across here. Now I would always suggest drawing these lines for your exam. I get 56. So now, so here we go. So 60% of the men took 50 or less. So now what I'm going to do is if I go here, I have 50. I'm going to go up to 50 and across, I'm going to get 42. Okay. And question A. Use the graph to find an estimate for the interquartile range. I know my interquartile range is my upper quartile minus my lower quartile. So I had 56 minus 38 is going to give me 18. Okay, then the next question says, 60% of the men took 50 minutes or less for the race. No women took 50 minutes or less for the race. Work out an estimate for the number of men who took part in the race. So 60% of the men took 50 minutes or less. So if I go back to the graph, so that means that 60% is 42 men. Okay, so I want to find 100%. Now, there are many different ways you can do this, but what you could do is divide both sides by 60 and multiply by 100, because that would essentially give you 1%. So divide by 60, multiply by 100. We're then going to get 100% equals 70. Okay, now again, you're going to get method marks for drawing on the graph, so please make sure that they can see. If they can see a complete method, then that's what that's going to give you more method marks. Okay, question 13. The diagram shows a solid cube. The cube is placed on a table so that the whole of one face of the cube is in contact with the table. The cube exerts a force of 56 newtons on the table. The pressure on the table due to the cube is 0.14 newtons. Work out the volume of the cube. Okay, so something that we really need to take note here is that when we're looking at pressure, we're just looking at area. Now, this area is only going to be the face here, which is on the table. So this face is the one which is exerting the force on the table. So that means our area is going to be W times W, which is W squared. Okay, so we know our pressure because it says our pressure is 0.14. We know our force because it says our force is 56, and we know our area is W squared. I always think it's really important to write these all out. So now when we're substituting it into this formula, we're going to have 0.14 equals 56 over W squared. Now again, we could use that little trick from earlier where we're going to get W squared equals 56 over 0.14. We're now going to square root the answer, because to get rid of a squared we need to square root. So W equals the square root of 56 over 0.14. Now remember, when we are square rooting, please have your positive and negative, because when we square root we could have either value. In this case, we cannot have a negative length. So when we get our answer, W equals plus or minus 20, we're going to have W is 20 or W is a negative 20. We cannot have a negative length, so we are going to reject the negative 20. But it's really good practice to make sure whenever we are square rooting that we are writing those plus and minus signs. So that means our W equals 20. And now wants us to find the volume, which is 20 times 20 times 20, which is going to give me 8,000 centimetres cubed. Okay, question 14. The diagram shows a parallelogram EFGH. EF equals 9.3, FG equals 14.7, angle EFG equals 106 degrees. Work out the area of the parallelogram. Give your answer correct for 3 significant figures. Oh, right, well, this is lovely, isn't it? Because if we have a look, we know a parallelogram we can split up like this. Now, if we have a look at this triangle, okay, we have 106, 14.7, 9.3. The first thing that should be coming to your mind is using a half AB sine C. Now, even though we're going to use a half AB sine C, we need to make sure, because we're only using half of the parallelogram, at the end we multiply it by 2 to get the whole parallelogram. Okay, so in actual fact, if we're going to multiply this by 2, you can just do AB sine C, because a half times 2 is going to give us 1. So in your calculator, you need to put 9.3 times 14.7 times our sine of 106, which is going to equal, I don't have my calculator on me, but it's going to equal 130 something, point something something. And then to 3 significant figures, that's going to give 131. Okay, so the answer is 131.414. Round to 3 significant figures. My third significant figure is a unit, so I'm rounding to the nearest unit, which is 131. Perfect. It then says, work out the length of the diagonal EG of the parallelogram. Okay, so it actually now wants that diagonal. So I'm going to be using cosine rule. Okay, so we're going to get a squared equals b squared plus c squared minus 2bc cos a. Okay, so we know, okay, our a in this case is different from our a when we used ab sine c. So So I'm going to substitute all of these values in, and you can just put it into your calculator in one whole thing. So my b squared, so I'm going to get 9.3 squared plus 14.7 squared minus 2 times 9.3 times 14.7 cos of 106. Okay, so I'm going to put that into my calculator, and I'm going to get a squared equals 377.9. To find my a, I'm going to square root 377.9. I normally keep that in my calculator as answer, so I just put square root answer. And then I'm going to get my a equals 19.4 to 3 significant figures. Okay, perfect. So that's question 14. Right, so question 15. We're going to find the volume, and it's a show that, so we need to make sure we show every step of our working. So it's already given us what the answer is going to look like. So if you go wrong, you're going to know. And because it's a volume and it's a cuboid, we're going to multiply them all together. Perfect. So 2x plus 5, 3 minus x, x plus 1. Okay, so I'm going to start by multiplying these two together. So I'm going to get 2x times 3, 6x, minus 5x, plus 15, minus 2x squared. I'm going to get x plus 1. I'm going to tidy that up. 6x minus 5x is x. Perfect. So minus 2x squared plus x plus 15. X plus 1. So I'm going to multiply everything now by x. So minus 2x cubed plus x squared plus 15x. I'm now going to multiply it all by a positive 1. Minus 2x squared plus 15. No. Plus x plus 15. So I'm going to get minus 2x cubed, x squared, that's going to give me minus x squared. 15x plus x is 16x plus 15 equals our volume. Okay, now I can make that look exactly how they want it by putting the positive values first in descending order. Minus x squared minus 2x cubed. Brilliant, therefore we've showed it. The volume, okay, because to find the maximum we can differentiate. When we find in the maximum, we want to know when is the gradient equal to 0. So when we differentiate, we find the gradient function. Putting that equal to 0 will allow us to find the maximum. So we're going to plus 6 minus x squared minus 2. Okay, so question 15, part B. There is a value for x for which the volume of the cuboid is a maximum. Find the value of x, show you're working clearly, give your answer correct to 3 significant figures. So when we're finding the value of x, to show it's a maximum, what we need to do is we are going to differentiate v equals 15x cubed. Okay, so what we're going to do is we are going to differentiate this to find the gradient function. So we're going to differentiate dv with respect to x. 15 differentiates to nothing. 16x differentiates to 16. Minus 2x squared, bring the power down. It's minus 2 and decrease the power by 1. And then minus 2x cubed, bring the power down. So minus 2 times 3 is minus 6x, and bring the power down to get squared. Now, to find the maximum, that is when we're going to find the maximum or minimum when our gradient function equals 0. So I'm going to get 16 minus 2x minus 6x squared equals 0. Okay, so if I'm going to solve this, I can use my calculator and I can go on the equation solver. Alpha A. And our A is minus 6, our B is minus 2, and our C is 16. Okay, so our A is minus 6, B is minus 2, and our C is 16. We're going to get minus 1 plus root 97 over 6, and minus 1 minus root 97 over 6, okay? Now, it does want this in terms of three significant figures. So I'm going to write down minus 1.8081. And then we also have 1.4748. Now, when we have our maximum, okay, we know that this is a negative quadratic. So our graph is going to look like this. So our maximum point here is going to be a positive value of x. So my maximum is at 1.47 to three significant figures. So then, moving on to question 16. So, question 16. Question 16. It's an upper and lower bound question, and what we're going to do is it says 58.4 is correct to three significant figures. So 58.4, I've got my upper bound 58.45, my lower bound 58.35. Okay, 20 has been rounded correct to two significant figures. So for my 20, I've got 20.5 or 19.5, and then 3.6 has been rounded to two significant figures, so 3.65 or 3.55. I think it's really good to make sure that we're writing our upper and lower bounds for these. Then it wants to work out the upper bound of P. So to find the upper bound of P, if I have a fraction and I want to find the biggest value of that fraction, how am I going to find that? I'm going to do that by finding the biggest value of the numerator and dividing that by the smallest value on the denominator. So to find the biggest value on the numerator, because I've got 2a minus c, to find my biggest value, I want my a to be my upper bound to give me my biggest values of a, multiply that by 2. Then I'm going to take away my lower bound of c, and then I'm going to divide that by my lower bound of d. So that's going to give me two lots of 58.45 minus 19.5 divided by 3.55. Okay, I'm then going to end up with 27.44. If I put this into my calculator, 2 lots of 58.45 minus 19.5 over 3.55 is going to give me 27.4366, and then rounded to 2 decimal places is 27.44. Okay, perfect. Okay, question 17. This was quite a nice question. It says show that, and you've got to show each stage of your working. So when we're showing that, first of all, we're going to have 6 plus 2 root 12, bracket 6 plus 2 root 12. Okay, step 1, I'm going to multiply out. So 6 times 6, 36. 2 root 12 times 2 root 12 is going to be 4 times 12, which is 48, plus 12 root 12, plus 12 root 12. 36 plus 48 is 84, plus 24 root 12. Now, root 12, I can actually change. The highest common factor, which is a square number, is 4. So root 12 can be written as root 4 times root 3, which is the same as writing root 4 times root 3. Root 4 is in fact 2. So I'm going to have 2 times root 3. So 84 plus 24 lots of 2 root 3 is 84 plus 48 lots of root 3. Now in the question it says we need to take out a factor of 12. If I take 12 out, I get 7 plus 4 root 3, which is correct. Therefore, shown. Okay, it's really vital that you show each of these steps. You need to show that root 12 can be rewritten as 2 root 3 by using these steps here, okay? Perfect. Moving on to part B. Simplify fully. 27a to the power of 12 over t to the power of 15, all of that to the power of negative 2 over 3. Well, first of all, to get rid of the negative, I'm going to flip the fraction. So I'm going to get t to the power of 15, 27a to the 12 to the power of 2 over 3. Now, to the power of 2 over 3 means if it was a number, I need to cube root it and then square it. If it's a power, for example, t to the power of 15, I need to multiply 15 by 2 over 3. So t to the 15 multiplied by 2 over 3 is in fact 10. So 27 to the power of 2 over 3, the cubed root of 27 is 3. Square it, we're going to get 9. And a to the power of 12, that power of 12 multiplied by 2 over 3 is in fact 8. And there is our answer. It's nice and simple. Okay, question 18 is a probability question. There are 16 sweets in a bowl. 4 of the sweets are blackcurrant, 5 of the sweets are lemon, 7 of the sweets are orange. Anna, Ravi and Sam each take at random 1 sweet from the bowl. Work out the probability that the 5 lemon sweets are still in the bowl. Okay, if you notice though, it wants the probability of 5 lemon sweets still being in the bowl, but we only have 5 lemon sweets in the bowl, so that means nobody is taking a lemon sweet. Okay, so it's quite nice, even though you think when you're drawing a probability you need to do 3 strands, you don't actually have to, because the probability is Anna could take a blackcurrant sweet or an orange sweet. So if she takes a blackcurrant, that's 4 out of 16. If she takes an orange sweet, that's 7 out of 16. Okay, so this is Anna. Okay, then after Anna, we have Ravi. So if Ravi takes a blackcurrant sweet after Anne's taken a blackcurrant sweet, there's now 3 out of 15. but there's still 7 out of 15 for the orange. If he takes a blackcurrant orange, if Anna takes an orange sweet and then Ravi takes blackcurrant sweet, there's still 4 left. But if Anne takes an orange and then Ravi takes an orange, he has 6 to choose from. Okay, and then we have Sam. So Sam still has the option to take a blackcurrant or an orange because we don't need to worry about the lemon. Okay, because the lemon, no one can take the lemon because we still want 5 of the lemons left. If he takes a blackcurrant after Anne's taken a blackcurrant, it's going to be 2 out of 14. If he takes an orange, there is still 7 out of 15. If Anne takes a blackcurrant and nobody takes and then Ravi takes an orange and then Sam takes a blackcurrant, there's now 3 out of 15. And then the same, if we take a blackcurrant and then an orange, this is now 6. Oh, sorry, these are all out of 14, everyone. 14. Okay, then if Anne takes an orange, Ravi takes a blackcurrant, it's 3 out of 14 left for Sam. If we take an orange, a blackcurrant, 6 out of 14. An orange, a blackcurrant, we still have 4. An orange, and then an orange is going to be 5 left out of 14. Okay, so we know that we could, there's multiple ways, so we could do blackcurrant. They could all take blackcurrants. Or we could have blackcurrant, orange. We could have blackcurrant, orange, blackcurrant, orange. Or we could have orange, blackcurrant, orange. Or orange, blackcurrant, orange. Okay, those are the only possible ways that we could do this. So, what we need to do is figure this all out. We know blackcurrant is 416 plus 3 multiplied 315 multiplied 2 14s. Okay? We know that they're all going to be over 16 times 15 times 14. So I can just work that out in the corner because this is going to be times 15 times 14 is 3,360. Okay, so the same denominator. So to get rid of some of the space, make more space. Okay, so for BBB, we're going to get 4 times 3 times 2. For BBO, we're going to get 4 times 3 times 7. For BOB, we're going to get 4 times 7 times 3. For BOO, we're going to get 4 times 7 times 6. We're then going to have OBB, 7 times 4 times 3. We're going to have OBO, which is 7 times 4 times 6. We're going to have OOB, 7 times 6 times 4. And then we're going to have OOO, which is 7 times 6 times 5. Perfect. So, now I'm going to work out all of these and add them all together. So 4 times 3 times 2 is 24. 4 times 3 times 7, 84. 4 times 7 times 3, 84. 4 times 7 times 6, 168. 7 times 4 times 3, 84. 7 times 4 times 6, 168. 7 times 4 times 6, 168. 7 times 6 times 5 is 210. So 168 times 3 plus 84 times 3 plus 210 plus 24 is It's going to give me 990. So then I'm going to have 990 out of 3,360. And that is the answer. Some of you may, if you put that into your calculator, have simplified it to 33 over 112. They will accept every way. Now, even though this method is by exhaustion and it's about listing every possibility, there is definitely a simpler way. We could just find out the oranges and then do 1 minus. The reason why I've shown you this way is because it's really good to understand what's going on and actually having a look at all the different possibilities. Which is, question 19. The diagram shows a cuboid A, B, C, D, E, F, G, H. EH equals 9, HG equals 5, and GB equals 6. Work out the size of the angle between AH and the plane EFGH. Okay, so there are a few different ways you can do this. What I'm going to show you is a new method that we haven't done before. So we need to work out the size of the angle AH and the plane. So what we want is, here is my AH, okay, and this is the plane at the bottom. We want this angle here. Now, in further maths and in A-level, when we deal with vectors, we can deal with them in 3D. And we can actually apply Pythagoras' theorem when we have a 3D shape to find from A to H. Now, to find the length of the line from A to H, we can actually do the square root of 6 squared plus 5 squared plus 9 squared. Okay, that's going to give us the square root of 142. So that line right there is actually root 142. Then what we need to do is, if we have that one, if we take this out now, so if I show you this right angle triangle, okay, this is A, this is H, this is F. We know this is a square root of 142. We now need to find this angle X. We know this length is 6. So all we need to use now is SOHCAHTOA. So we have our opposite, our hypotenuse, our adjacent. We do not need the adjacent. Okay, so then we're going to have O and H, which is sine. So we're going to have sine X equals 6 over root 142. X equals sine to the minus 1 of 6 over the square root of 142. So 6, shift sine, 6 over root 142. Where I am now. Oh, here we are. Which equals 30.232. What's 3 significant figures? 30.2 degrees. Okay, question 20. So for question 20, we have a graph. Using the axis below, sketch the curve. C. On your sketch, show clearly in terms of A. So first of all, when I'm looking at this, okay, I know this is going to be a positive quadratic function. I know my minimum point is going to be when x equals 1 and my y is equal to negative a. Okay? What I also know is that I could solve this, okay? So if I was to solve this, I'm going to get, so this is my minimum point here. y equals, if I put this equal to 0, to find my roots. So 4x minus 1 squared minus a equals 0. So 4x minus 1 squared equals a. X minus 1 squared equals a over 4. X minus 1 equals plus or minus the square root of a over 4. X equals 1 plus or minus the square root of a over 4. So this is going to be my root where it crosses. So I'm going to get 1 plus root a over 4, 1 minus root a over 4. Now, a is greater than 4, okay? So we know, if, for example, let's choose a equals 5. If we put 5 in here, a is 5, we're going to get a positive value because we're going to have 1 plus root 5 over 4. Here, the square root of 5 over 4, if you were to just put that into your calculator, just to visualise what's going on, you're going to get 1.1, okay? It's bigger than 1, so this we know that our minimum is going to be around 1 minus a. So we could call this a. So now I'm going to draw my graph. Okay, that graph's terrible because that's our minimum needs to be the lowest point. Oh, that's even worse. Wait there. Do you know what I'm going to do? I'm going to get rid of this dot here. Okay, I've got this. Right. Perfect. So you can see this needs to be our minimum value. So we're going to have our minimum value here of 1 minus a. We know this value here is going to be 1 plus root a over 4, 0. We know this value here is going to be 1 minus root a over 4, 0. And then the only thing we're missing is our y-intercept. Our y-intercept happens when x equals 0. So in this formula, when x equals 0, we're going to get 4 lots of minus 1 squared minus a, which is going to give us 4 minus a. So this point here is 4 minus a. Okay, so that is how we draw this graph. Question 20 is actually quite a difficult question in terms of it's not using numbers. With the a, it throws a lot of people off. But you just need to do what you would normally do for these types of questions. Question 21. The functions f and g are such that f of x equals x squared minus 2x and g of x equals x plus 3. The function h is such that h of x equals f of g of x. Okay, this means instead of writing x, we're going to put g of x in here, okay, because it's f of g of x. So f of g of x is, instead of writing, so remember, this is x squared minus 2x, and what we're going to put in is g of x. So we're going to get x plus 3, x plus 3. So x plus 3 squared is x squared plus 6x plus 9 minus 2x minus 6. So you're going to get x squared plus 4x plus 3. Okay, and this is f of g of x, which we know is now h of x. It then says express the inverse function of h to the minus 1. Now, when we have an x squared, when we have a quadratic and it wants us to find, we want to replace our x's with y's and then rearrange. So we're going to get x equals y squared plus 4y plus 3. When we're rearranging a quadratic, we need to complete the square. That's the only way we can rearrange it. So we're going to get y plus 2 squared minus 2 squared plus 3. So So x equals y plus 2 squared minus 4 plus 3 is negative 1. Now we have it in this form, we can rearrange it. So we're going to add 1 to both sides. Equals y plus 2 squared. We're going to square root. Now when we square root, we need to make sure we put in our plus and minus. Square root x plus 1 equals y plus 2. And then if we take away 2 from both sides, we're going to get minus 2 plus or minus the square root of x plus 1 equals y. Okay, so then we have our inverse function. Now, in this case, at the end, make sure you write the answer in the answer box. Okay, question 22. Triangle HJK is isosceles with HJ equals HK and JK equals root 80. H is the point with the coordinates, J. Okay, step 1. Draw a picture. So the triangle HJK, HJ equals HK. Right, so I'm going to draw quite a big picture. Okay. These two are isosceles. I'm going to call this H. This is J. This is K. This is root 80. Brilliant. H is the point with the coordinates minus 4, 1. J is the point with the coordinate J, 15. Okay. And K is the points with the coordinate 6k. Okay, realistically, even though I've drawn this picture, it's going to be the other way around. I think it's going to look somewhat like this if we were to draw it with these two being isosceles. It doesn't really matter for now, okay? You've just, as long as you're drawing a picture so you can visualize it a little bit. Then it says M is the midpoint of JK. So here is my point M. And the gradient of HM, so this gradient is 2. So dy by dx equals 2. Okay then. So, knowing all this information, we need to try and figure out what the value of J and K is. Okay, first of all, because M is the midpoint, and we know that from M to H, okay, which is directly above it, and because it's an isosceles triangle, it means that the gradient of M is actually perpendicular to the gradient of JK. So that actually means that the gradient of HM multiplied by the gradient of JK has to equal minus 1 because they're perpendicular. Now this is because it's an isosceles triangle, okay, and M is the midpoint. So if I was to find the gradient of M of JK, I know that 2 times the gradient of JK is minus 1. So JK, the gradient of that must be minus a half. So how do I find the gradient of 2 points? I'm going to do the difference in y over the difference in x. So I'm going to get k minus 15 over 6 minus j equals negative a half. Okay? So I know we have one equation so far. So I still have 2 unknown variables though, okay? But with these unknown variables, I need to try and figure something out. Now, what else do I know that I could work out? Well, hold on a minute. I know the length of this line here. Okay, and how do we find the length of a line? We do Pythagoras. So if you imagine this is my J and my K.
Is that Ali?
Okay, so I have my J is J15, and then I have my K is 6K here.
Oh, Ali, can you hear me now?
To find that length, we know that's root 80.
Ali, can you hear me now?
So now, okay, I can use, so between J and 6, so this is J minus 6, and then this length here is K minus 15. Okay, so what I need to do now, if I square both of these sides and add them, I'm going to get root 80 and square root them. So what I actually don't need to do is when I'm using Pythagoras now, normally I'd do a squared plus b squared equals c squared and square root. Yeah, so what I'm actually going to have is j minus 6 squared plus k minus 15 squared equals 80, because root 80 squared is 80. Okay, so now I'm going to have, I can multiply this all out. So now I have two equations. So these are my two equations. I need to rearrange one to get either k equals or j equals. And then I can substitute that into my second equation. So I'm going to rearrange this to get k or j equals. I'm going to substitute it into this. I'm then going to solve it. I'm then going to get some values for j and k. So then what we're going to do is simultaneous equations. Okay, so here we go. Just one. So we're going to rearrange the dy by dx. If I rearrange this one, I'm going to do that here. I'm going to get k minus 15 equals negative a half bracket 6 minus j. K minus 15 equals negative a half times 6 is negative 3. Negative a half times negative j plus j over 2. I'm then going to move the 15 over. So I'm going to get 12 plus j over 2. Okay, so now I have what k is. I'm going to substitute that in to this one here. So I'm going to get j minus 6 squared. I'm going to get j squared minus 12j plus 36 plus 12 plus j over 2 minus 15 squared equals 80. So that's going to give me j squared minus 12j plus 36 plus j over 2 minus 3 squared equals 80. So I'm going to get j squared minus 12j plus 36 plus j squared over 4 minus 3 over 2 minus 3 over 2. So we get minus 3j plus 9 equals 80. Okay, so now I'm going to I'm going to add like terms. So I'm going to get j squared plus j squared over 4, 5j squared over 4, minus 12j minus 3j, minus 15j, and then we're going to get 36 plus 9 plus 45 equals 80. Now what I'm going to do is multiply everything by 4 to get rid of this fraction. So 5j squared, 45 times 4 is, 15 times 4 is minus 60j. 45 times 4 is plus 180. Equals 320. So now I'm going to divide everything by 5. So I'm going to get j squared minus 12j. I'm going to move that 320 over. So 180 minus 320 is minus 140. Divide that by 5. I'm going to get minus 28 equals 0. Okay, now I'm going to solve this. I hope I haven't made a mistake here because I've rushed this one. So then let's see. Perfect. So my A is 1, minus 12, minus 28. I get x1 equals 14 and x2 equals minus 2. Okay, so I have two values for my j here. I have 14 or minus 2. Right, let's put these values in to find k, and then we might be able to see which ones. It says, in the question it says j is less than 0. Brilliant. So we're going to use this one. So we're going to reject the positive. So reject. Right, so j equals minus 2 and k equals 12 plus minus 2 over 2. So k equals 11. Brilliant. Question complete. Is going to